You guys at home should be ready to rock and roll. Here's the screen sharing. And today we're going to start chapter 3. Woohoo! All right, we're going to start chapter 3 today, and this is going to get into some of the material that you guys have probably dealt with a little bit already. Okay, so on my screen I've got 3 warm-up quizzes. I want you to go ahead and knock those 3 out, and then we will we'll go over with the great rapidity and certainty what your answers should be for these. Mm-hmm. 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 Open this window up. Get a little airflow going up in here. Hopefully not a little bit of some mosquito flowing. All right, Georgie boy, what'd you do on this first one? What'd you get? All right, how so? Boom goes the dynamite. Well, multiply first. 5 times -1 is -5 minus 4 is another -9. Easy peasy. We're plugging in one variable. Now let's plug in Will Edwards' 2 variables. Go ahead. Tell me what to do.
I just got 18.
Oh, how now, brown cow? Your work was messy. So let me ask you this. What's a negative times a negative, class? A positive. So 2 times 3 is going to yield that 6. That's going to give us indeed our 18. So not too bad. Just make sure that work is readable. And then in this last one here, we'll ask Tiago to get y by itself. And Tiago, I want you to tell me what 2 steps you use to get y by itself. You got to unmute yourself first, Bubba.
Sorry.
That's all right.
So first I subtracted 8 from 20.
Mm-hmm.
Then I divided by 3.
What kind of 3?
The -3.
Uh-huh. And what'd you get?
Y equals -4.
Perfect. And boom goes the dynamite. All right, so 3 good little questions for us here. Jack, I've got a 4th question for you. What's a dentist's favorite animal? A molar bear. What time should you always go to the dentist, Mr. Wendt? That tooth hurty. 2:30? Yeah? Nobody appreciates dental humor these days. That's all right. Moving on. Let's talk about graphing. Did you know that when we graph things out, we do so on what is called the Cartesian coordinate system? Have you heard that phrase before? Cartesian, do y'all know what Cartesian means? Why do they call the XY plane the, quote, Cartesian plane? Well, it's named after somebody. It's named after a French mathematician and philosopher named René Descartes, right? So the word Cartesian describes of Descartes So this is the Cartesian plane, XY plane. It's got an x-axis. I bet you knew all that already, didn't you? It's got a y-axis. X goes left and right. Y goes up and down. Where are the positive x values, Grove? Give me left, right, up, or down. To the right. Our positive x values are to the right. All right, Joe Edwards, where are our positive y values?
Up.
Yeah, up. And conversely, our negative x values would be to the left, and then our negative y values would be down at the bottom. We call the crossing of our x and y axis the what, George? It's on the screen. The origin. Very good. Can you write that word down? The origin has coordinates of 0, 0. Oh, and by the way, I mentioned coordinates. When we plot points in ordered what? Very good. Ordered pairs. And it's alphabetically ordered. Ordered pairs. Okay. And so we're going to talk about the 4 quadrants. And we use Roman numerals to number the 4 quadrants. We start in the top right-hand corner. And again, you probably have seen some of this before, but we go 1, 2, 3, and then 4. The bottom right-hand being the 4th quadrant. We rotate around in which direction? Counterclockwise. Do you know what they call counterclockwise in Great Britain? Anticlockwise. Little trivia fact for you. So if you're ever doing some algebra and you're overseas in the land of the Brits, you can use the proper word, anticlockwise. I've got an orange there, what's called an intercept. Okay, you ever heard of a police interceptor? You guys know what a police interceptor does? It's like a souped up fast car. It's usually like a Dodge Charger or something like that, where if they need to chase somebody down, they get in the police interceptor. So that what they can do is if I'm the bad guy and I'm driving like this and the police are going to try to cut me off, they're going to intercept me. Well, if our graph, like I've got a line graphed here, if our line intercepts the y-axis at the point 0, 3, we call that our y-intercept. Okay. Notice the x-coordinate. Are y'all not running? I want to see this whole dadgum picture in everybody's notes right now. For Pete's sake, y'all are sitting here like a bunch of dadgum, I don't know what, like a bump on a frog's butt, maybe. My goodness. Same thing for the x-intercept, except the x-intercept has 0 as its y-coordinate. Because again, you're on the x-axis, you're not going up or down any. So the y-coordinate would be 0. Whereas with the y-intercept, the x-coordinate is 0 because you didn't move left or right any. And of course, the origin there is 0, 0 because we didn't move to the left or to the right or up or down. Good old René Descartes is quoted with a famous philosophical quote. He said, "I think, therefore I am." Very good, Mr. McBee. I think, therefore I am. So one day Descartes walked into a bar, sat down at the bartender, and the bartender said, "Hey, René, would you like a drink?" He said, "I think not." And poof, he disappeared. A little math humor there for you. Get it? Because he thinks not. Did you hear that joke?
It's a good one.
I know it's a good one. Oh, me. Now we're going to start learning to graph lines. Okay, linear functions are our basic types of functions. This year you'll learn also how to graph out parabolas, which are from quadratic functions. Now I wouldn't teach you how to graph parabolas first because that would be putting Descartes before the horse. Oh, corny joke number 4 of the day for those of you that are keeping track. I made a commitment this morning on my drive into work. I said, I'm going to tell 5 corny jokes today to my 8th graders and see if any of them laugh. None of y'all have laughed so far. So you're hurting my heart here, Lewis Thomas. You're hurting my heart. Okay. All right, let's move on into our first example, and we're going to practice plotting some points. This should be easy peasy lemon squeezy for you guys, okay? All right, we're going to plot these points out. Now, we're going to label them with the letter A, B, C, D, and E, okay? One thing I tried to get you guys into the habit of doing is making what are called equidistant tick marks. Okay, Charlie, describe what an equidistant tick mark is.
If I had to guess, I think marks that are like an equidistant apart.
marks that are an equal distance apart. Okay, you literally used the word right there to define itself. Absolutely right. So in other words, my tick marks, I'm trying to space them apart. I'm not using like graph paper or whatever, but I'm trying to make my tick marks equally spaced. Because look, what if I did this? If I did like, is that a helpful way of labeling my axis? Pete's sake, no way. Okay, I want to be more precise. I want to have them equally spaced so that everything can be to scale. What it means to be to scale is that it's not warped out in one direction or another. In other words, 1 unit up is the same distance as 1 unit to the right. And you don't have to make a boatload of tick marks. Actually, what I encourage you guys to do is just check and see what's the largest number that's negative and the positive for each direction, and you can therefore allocate enough tick marks. So like I don't have to go anywhere farther than -5 to the left. Okay. So if I wanted to plot point A, right, in which quadrant, Nate, would point A be? Second quadrant is correct. We go 5 to the left, 3, 4, 5, and we go 4 up. 1, 2, 3, 4. And there's where A is. Excellent. Okay, Jake, which quadrant, in which quadrant is point B?
Quadrant 3.
Quadrant 3, bingo. This is easy, isn't it? This is like cake. I'm feeding you cake for breakfast. You're welcome. Andrew, point C. In which quadrant is point C?
Quadrant 4.
Quadrant 4, good. We go 2 to the right, we go 3 down. There's point C. All right, Paul. Paul, in which quadrant is point D? Earth to Paul.
Quadrant A. Quadrant A. Sorry, I didn't know my mic was muted.
What the dump do you mean quadrant A? There's no such thing as quadrant A. We've got quadrant 1, 2, 3, and 4.
Quadrant 2.
Quadrant 2. Try again, Paul.
Quadrant 1.
Try again, Paul. You can't see I'm smiling behind my mask. Go ahead, buddy.
Wouldn't it be like the Y?
I'm asking Paul the questions here, Lewis Thomas.
Wouldn't that really not be in a certain quadrant because it's on the y-axis?
Very good, Paul. You smelled out my trick question finally. Good job, buddy. This one's between two quadrants, isn't it? It's on an axis. Now, if we were graphing a function, if we were graphing like a linear function, that would be its y-intercept. That's where it hits the y-axis, for example. All right, and then last but not least, in quadrant number 1, we go 3 to the right, and we go about 2 and some change, 2.5 would be where point E is, right? Now look, 5/2 or 2.5, right? Even though that's not an exact, that's not on a tick mark, we can still approximate it where it's located, okay? You ought to be able to approximate, decimals and fractions in a relatively accurate manner, okay? You heard me say 2 and some change, so I moved up 2, and then I kind of eyeballed it to see about halfway between, 2 and 3. Graphs are not meant to be super duper accurate, but the more little things that you could do along the way to make them better, all the more accurate you guys will be. All right, woohoo, here we go. Getting into some big boy stuff now. When we talk about, I've used this phrase linear before, okay? Linear refers to a relationship between x and y such that when we plug it into an equation, it can be put into this form, ax plus by equals c. Guys, this is what's known as the standard form of a linear equation. All right, can you write that down in your notes? You're going to be required to know from memory. I'll come in and I'll say, hey, tell me, Joey, what the standard form of a linear equation is. And Joey would say ax plus by equals c. All right. A, B, and C are numbers. They're constants, okay? A and B can't both equal 0 at the same time, and therefore we've got what's called a linear equation of 2 variables. Your 2 variables, by the way, are x and y, aren't they? We're used to that. You saw some of that in the warm-up today, okay? And the very first day that we had class this year, fellas, I told y'all, what does it mean to solve an equation, right? We said to find any and all of the numbers that when plugged in for the variable or variables make a true statement. So when we talk about a linear equation, what we're for when we talk about its quote solution is we're looking for all of the ordered pairs that when you plug in their x and their y together, they make a true statement. And therefore, all of those ordered pairs would represent points on the line. Okay. So if you look at example 2 here, it's just a real quick identification. Which of the following are linear equations? In other words, which of the following, if we manipulated them a little bit, if we tweaked them, changed them around, use inverse operations, if we manipulated them to be put in the form ax plus by equals c, they would be considered linear. Okay, which of the following? So you guys at home with either a thumbs up or a thumbs down, you guys here in class with either a thumbs up or a thumbs down. What about part A? What about A? Is that linear? Thumbs up if you think so, thumbs down if you think no, thumbs sideways if you're like, yeah, I don't know. Okay, all right, I'm seeing some sideways thumbs, some upside down thumbs, and some right side up thumbs. This one is linear. Look at the form it's in. So we needed to say thumbs up there because this is ax plus by equals c. I'm going to zoom in so you guys can see this a little bit better. All right. Now, what would my a value be? What would my a value equal? Mossy, can you tell me what would a equal on that one? Speak up, Valentina. I saw you unmuted yourself for a moment.
A would equal 5.
A would be 5. Okay, very good. Luke, what would b equal? And be careful here, Luke. What would b equal? What do you think?
You have to, I think 6 or 7.
All right, so I see the number 7 that's in front of y, but notice what we've got here. We've got plus by. So how could I write what's in black there? How could I write 5x minus 7y equals 14 using a plus sign? What do you think? It'd be 5x plus what?
I don't know.
All right, let's just throw the negative with the 7. So in other words, my b value here would be negative 7. Okay? And then class, of course, what's c? 14. All right. Being able to identify what a, b, and c are is an important skill, okay, for a linear function. Now, part B, let's do our thumbs up, thumbs down, thumbs sideways again. What do we think? Is that a linear equation? All right, so I've got several thumbs down. I've got a couple of thumbs up. I've got some sideways thumbs. Okay. Let me ask you this. Let's take time out just for a sec. Y equals 1/2 x plus 3. All right, I'm going to do 2 steps. Watch the 2 steps that I do. Okay, first step, I'm going to multiply everything by 2. 2y equals x plus 3. Next step, I'm going to subtract x from both sides. Negative x plus 2y equals 3. What do we think now? Brave Jack McBee over here. He's had his thumb up the whole time. That's a linear function. It was just in a different form, wasn't it? Does anybody know what form it was in to begin with? What do we call when it's in that y equals form? Have y'all learned that yet? Not so much. You ever heard of y equals mx plus b? You ever heard of slope intercept? Have y'all's teachers thrown those words around yet? Maybe a little bit. We're going to talk a buttload about y equals form, okay, this year. And so what we just learned is that you could take an equation that's not in standard form, and although it's not in standard form, we can manipulate it. We can put it in standard form. Okay? So this certainly is, part B is, much like part A linear equation. We weren't asking which of the following are in standard form. We were asking which of the following are linear equations. Let me give you a little tip. Okay? Here's a little tip. It's linear if the only variables that you see are x to the first power and or y to the first power. What I mean by power is exponent, right? So like if I see x squared, automatically I know that's nonlinear. If I see y squared, automatically that's nonlinear. If I see something kooky like the square root of x, nonlinear. But if all I see is an x to the first power and or a y to the first power, then it's gravy. Okay? So what do we think about part C? Big time, nonlinear. That's a cubic equation right there. Nonlinear. So very good, because it's got x cubed, it's got x squared, it's got things other than just a simple x and y. All right, what about part D? This one could be tricky. What do we think? I'm seeing some thumbs down. All right, check this out. This one's actually linear. And you're like, what? Here's why it's linear. I can express it in the form ax plus by equals c. Watch this. Okay. Square root of 5 times x plus 0 times y equals 8. Let's do that same little exercise again. Read, what's my, quote, a value in that case? Yeah, very good. So a would be my square root of 5. Okay. Colin, what's my, quote, b value in this case?
0.
Yeah, very good. 0. And then class, what's my c value? 8. So go back in your brain and think back when we were earlier in chapter 2, when we learned about manipulating formulas. You guys remember doing that? Where I would give you the formula like a equals 1/2 h times sum of b1 plus b2, area of a trapezoid. And I would be like, hey, solve for b1. And you had to kind of move things over to the other side, isolate b1. That manipulating exercise is going to pay off in dividends over here. In other words, it's going to be very helpful for us if we can manipulate some equations. All right. To let the cat out of the bag here, the fifth one is non-linear because I see what? I see y squared. And anytime it's got an exponent of other than 1, then I know it's going to be non-linear. Okay. So what we were able to do is we were able to identify a linear equation by the fact that it could be expressed in standard form, also by the fact that it had x to the first and or y to the first only. Okay, that is a very important skill if you're smelling what I'm stepping in. Okay, BT dubs, I gave you guys a little bit of some homework earlier in the week. I don't think I made an announcement about it. But if you go on Delta Math, there was some, I think I've got 1 or 2 assignments that I've given about inequalities just to kind of wrap things up for us all. All right, so you guys can work those at your leisure. And then also, if you have a CBHS account that works, like you figured that one out, then you can also go on to Teams, and there's a little ACT practice number 8 that you can work on this week too. As far as homework goes, that's 3 opportunities for you guys to practice this week, okay? All right. Now we got about 8 minutes. This will probably be our last example. Okay, so go ahead and copy it down. Example 3 here. We're going to consider the following equation: 2x minus y equals 3. And the first thing we're asked to do is graph the line. Now that's making the assumption that you know that's a line already. Hopefully, after our previous example, that makes sense. It is a line because it's in the standard form. It's got x to the first, y to the first. Okay. Now, here's how I'm going to teach you to graph a line. I'm going to teach you 2 ways initially. Okay. The first way that I'm going to teach you to graph a line is using intercepts. Do we remember what we talked about intercepts? What were those intercepts? What does that mean? Somebody tell me. Jake, I haven't heard from you yet. Jake, what are our intercepts? What does that mean?
Where ordered pair crosses either the x-axis or the y-axis.
Good. So like just for kicks and giggles, I'm going to draw this line. This is not the line that we're going to end up drawing. But like if this were my line, right, it would have an x-intercept and it would have a y-intercept. So being able to find the 2 intercepts is a helpful way to start off graphing a line. What do we know, Joey, about the y-intercept? We know one of the 2 coordinates of a y-intercept. What do we know? 0 goes in for which coordinate? The x one or the y one? The x one, okay? Because think about it, on that y-axis, am I moving anywhere to the left? Am I moving anywhere to the right? No, I'm moving 0 units to the left and the right. So let x be 0. Okay, watch this. I'm going to type this up so it'll be a little bit faster than handwriting it. To find the y-intercept at x equal 0. Okay, let's do that. Now, I like the cover-up principle, which means if I'm going to plug in x equals 0, I might as well just cover up that x term. Because what's 2 times 0, class? 0. All right, and if negative y equals 3, then who could tell me what y should equal? Negative 3. We just divide both sides by negative 1. So y equals negative 3. That's my y-intercept. That's easy, easy lemon squeezy right there. Y equals negative 3. There's my y-intercept. Okay. Question, Jack? No? Oh, thought I saw a hand up. All right. Similarly, what do you guys think I could do to find the x-intercept? I call it out. Very good. Let y equal 0. Please write those 2 things down that I just typed in there. To find the x-intercept, we're going to let y equal 0 for the same daggum reason. If I'm on the x-axis, I'm not moving up any. I'm not moving down any. I'm just staying put right there on the x-axis. Now, I'm going to use a cover-up principle again. I'm going to cover up the y term because minus 0 is, superfluous. I don't need to say 2x minus 0. Just say daggum 2x. All right, so what would I do, Grove, to both sides to get x by itself in that case? Can you do that? Yeah, can we do that in our head? Divide by 2. 3 over 2 is 1.5, okay? So I can very easily, what did I tell you guys earlier? To ballpark it, I could very easily put a dot right, put a dot right there. Now, in geometry next year, you will learn many things. One of which is that 2 constitute a line. 2 points constitute a line. Between any 2 points, there exists one and only one line, okay, in Euclidean geometry. So I could draw a line right now, and it probably won't be a very good one because I don't have a ruler. That ain't too bad. I missed the x-intercept just a wee bit. I could draw a line right there. I could complete part A. Okay, that is one way to sketch a line, is to find its intercepts. Okay, everybody got that? Another way to sketch the line would be just to plug in some rando point and find what its matching coordinate would be. So like, for example, if I said, here in blue, we'll say, let x equal 1. Let x equal 1. Gee golly, I wonder what y will equal then. Okay, so just take x, and we're not going to do cover-up principle because it actually has a value there. So we got 2 times 1, which is 2. We got 2 minus y equals 3. Let's subtract 2 from both sides. Negative y equals 1. So what would y equal then? Negative 1. We would divide both sides by the negative, and we'd get y equals negative 1. So when x equals 1, whoops, pardon me, y equals negative 1. So I need to clean my graph up a little bit. What did you notice when I finally put in a third point? My graph looked a little better. Or at least it should look a little better. So what that should tell you then is that the more points we have on our graph, the better. Can we write that down? The more points that you have on your graph, the better. Okay, I do a lot of woodworking in my shop out in the backyard. And part of woodworking is sometimes where you have to rip a sheet of plywood. Okay, so I'm gonna take time out just for a sec, talk about plywood. Okay, y'all know a plywood, big sheet of plywood is 4 feet by 8 feet long, right? And the wood grain, usually the wood grain runs the long direction like this for the most part. Although with plywood, they've got different sheets, different plies, and they run or perpendicular to one another. But anyway, I digress. So we're going to rip this plywood. And what we're going to do is I'm going to say, you know, 4 by 8, I don't need 4 by 8. I need 3 by 8. So I need you to cut a foot off of the ends. Now, if I'm out in my shop and I just made a mark at the end of where I've done it on my green rectangle here of 1 foot in from the side on the top and 1 foot in from the side on the bottom, and I started cutting, that would suck. That would not be very good because I would get off kilter. You know, my saw would be all wiggy waggy and I would not have a nice straight edge. How could I make a straight edge? Draw a line. More points equals better line. So like I know I don't have an 8-foot ruler, right? And a tape measure is kind of a crappy way of drawing a line because it can get pushed off. So what would I do? I would measure and I would put many points with my mark, you know, a foot away from the edge, and that would make it easier to draw my line. The more points you have, the easier it is to draw your line. Okay, so in my algebra class, I like you guys to have 3 points on every line that you draw for me. Can you write that down? That's good old Coach Morgan's requirement for drawing lines. Is I like for you to try and put 3 points on the line. In geometry, we will learn that you only need 2 points to constitute a line. It's very true, but if you want a good line, more points will make it better. Okay, more points will make it better. All right, when we look at part B, it says are 0, -3, are 3, 3, are 2, -3. Are these points solutions to the equation? How could I answer that question visually? Like I know I could plug them in and see if I get a true statement. That's algebraically. I want visually. What would I check to see? Jack? Are they on the line? So like 0, -3, we know is on the line. So yes, it is a solution to the equation. 3, 3, we go 3 to the right, 3 up. It looks like it is on the line. We'd want to verify it algebraically, but it looks good to me. All right, 2, -3, not on the line, therefore not a solution to the equation. And -1, -5 looks like my cursor would work here. -1, -5 looks like it is on the line. So the takeaway from part B is that if you want to determine whether or not a point is a solution to the equation, okay, then you need to realize if it is on the line, then it is a solution, and vice versa. If it's a solution to the equation, then it is on the line, okay? And I say in part C, which points are on the line? All 3 of the ones we put a check mark next to. By the way, how many points are on this line altogether, all total? Tiago? Go for it, son.
6.
6? That's interesting. There are an uncountable number of points on this line. There are infinitely many points on this line. How do I know that? And lines do what? Keep going and going and going. They don't stop. Ooh, man, we're late. I gotta let you guys go. Y'all pack up, head out. We'll talk more about lines tomorrow. I can sit here and talk all day long. But if we talk too long, then when you get to your middle school, you'll be standing in line to get in. Okay, that's your 5th corny joke of the day. Mission accomplished. All right, fellas, live Jesus in our hearts. Thank you so much. Y'all have a great day.